Hey everybody, welcome to the next episode of the Project Euler Archive series. My name is Jake and I make programming videos. If you like these videos, please subscribe to help me grow the channel and like this video. Alright, so this problem is largest product in a grid, problem number 11 on projecteuler.net. So in the 20 by 20 grid below, four numbers along a diagonal line have been marked in red. That's 26, 63, 78, and 14. The product of these numbers is 1.7 million something. What is the greatest product of four adjacent numbers in the same direction in this grid? All right, so to start, I've already copied this grid into my file, but it's not formatted properly. It's just a bunch of strings, and we need to convert this into a grid of integers. So the way we'll do this is for each row in the grid. So for row in grid, I'm going to make this like a one-liner Python hack thing, list comprehension, so it's going to be a little hard to read, but bear with me. So for row and grid, we'll take for I in row dot split. So what this will do is go for each row in the grid, and then for each row we'll split the row on a space, and then for I in row dot split, take int I. So that's kind of weird, but that's just the reality. So let's just test this to make sure I did that properly. Dot pi. Yeah, okay, so we got this grid now, and they're all integers, and it's proper. We have 8, 2, 22, 97, 8, 2, 22, 97, so it's working properly. Great. So now the real trick of this problem is how to iterate through this grid properly. So the way I think about this is that there's four different kinds of groups. There's the horizontal groups, so where you'd have 8, 2, 27, 97. There's the vertical groups, 8, 49, 81, 52. And then you could have diagonal right groups, so that would be like 55, 60, 63, and 2. Or the diagonal left groups, so 60, 51, 60, 81. So there's horizontal, vertical, diagonal right, and diagonal left. All right, so let's begin. Let's just get right to it. So for the horizontal ones, also before I do this, I'm going to make a limit variable, set it to 20, just so I don't have to keep writing 20. I can just write limit, and you'll see why in a moment. So for the vertical ones, for I in range limit, so I represents the row we're on. We're going to go right from the beginning to the end. We don't need to adjust for any out of range index for the horizontal category. And then we'll go for j in range limit -3, because we're not going to go all the way to the end when we're iterating through for each value in the row, or else we'll get a list index out of range error. So then what we have is we have our grid, or let's call it a group. So our group would be grid at I and j, grid at I and j plus 1, grid. I'm just making this a literal. I could do this in a loop, but it's only 4 values. I don't mind. Grid at I and j plus 3. Okay, so as you can see here, this list, what this represents is, we start from the beginning where I and j are 0, and we would get 8, 2, 22, 97. And as we continue to do this, 2, 22, 97, 38, it will just iterate through like that, and then move on and do it for all of the rows. So that'll give us all of the groups of horizontal rows. And then I'm going to have some variable largest to keep track of the largest product we've seen up until this point. And I'm going to say largest equals the max of largest, or the product of group. Prod isn't a function, so I actually have to write that function. It's very easy. I just want a function prod that's going to take in some list and return the product of all of the numbers in that list. So have some variable results to keep track of it all, and then for I in li results times equals I return result. All right. So that's how you do it for all of the horizontal groups. For vertical, for all these groups, I'm just going to copy and paste them all here and then modify them as we need to. Okay, so for the vertical groups, we're not going to be able to go for I in range limit because since we're going down, we actually have to stop at the limit minus 3. So limit minus 3. So that'll get us up to, you know, this row. And then j can actually go all the way, because the last vertical group we'll check will be 36, 16, 54, and 48, and that'll be when I is at the limit minus 3, and then j is at the limit. Okay, and then our group here, it's going to be, instead of j incrementing by 1 each time, we'll have I incrementing by 1 each time, because we're increasing the row but not increasing the column value. So I plus 2, and then I plus 3, and j remains the same. Okay, yeah, and then this line would also remain the same. For diagonal right, we still get to start here, and we're going to go, for I, we're going to go up to the limit minus 3, and for j, we're also going to the limit minus 3, because the last group of diagonal right numbers we're going to check is going to be 40, 4, 5, and 48. So that's at the fourth last row and the fourth last column. So that's our limit there. So it's going to be limit minus 3, limit minus 3. And then our group, we get to add 1, I plus 1, j plus 1, I plus 2, because we're going down a row and moving down a row and over one column each time. Okay, just like that. Yeah, that looks good. And then for diagonal left, we don't actually, so for, for I, for the rows, we're going to go through all the rows up until limit minus 3, but instead of cutting off our ending, we only get to start at the third index, right? Because if we started at 8, we can't go diagonal left. From 8, the first value we can go diagonal left from is 97, so it'll be this column, 97, 40, 73. So for I in range, limit minus 3, and then j, it actually goes all the way up to limit, but it starts at 3, like that. And then our group, we go down a row each time, so I plus 1, I plus 2, I plus 3, and then from j we minus. Okay, and then if we print largest at the end of all of that, that should be our answer. Okay, I get this number. Let's see. This problem, by the way, is not very difficult. It's just tedious and like doing all of the, accounting for I and j. There's no like complicated algorithm you have to use. It's just implementing how do you iterate through a grid like this. Anyway, we got it right. That's pretty cool. Yeah, nothing else I got to say about this one. I'll see you in the next video.